So in this video, we're going to look at multiplying and dividing polynomials. Basically, polynomials are pretty much, most of the time they're like anything we really see in math. But specifically, we're going to be talking about like expressions with 2 terms or 3 terms, something like that, which we call 2 terms. We actually call that a binomial. And then 3 terms, we call that a trinomial. And then I guess another common one you'll see, if there's 1 term, we call that a monomial. All right, but all of these are examples of polynomials. They all fall in that category of polynomials. So let's start off with this. Let's start off with multiplying, and let's just lay down some ground rules. So step 1 is we're going to distribute, or we will FOIL. And if you don't know what FOIL is, I'm probably going to make another video at some point that just focuses solely on FOIL. Basically, FOIL is a method of distributing, which you do first, outer, inner, or first, outer, inner, or inside. I guess it would be inner. Yeah, let's do that. Inner, and then last. All right, so I'll talk about that more as we do the problems, but that's what I mean by FOIL. And then our second step is going to be to combine like terms. And then typically we write our answers in standard form. Now, for some people this is not a big deal. For some people this is a big deal. It all just depends. But basically you want your exponents in greatest to least order. So like if we have x to the third and x squared and x, we want to put those in order from least or greatest to least. All right, so now let's actually work on a few problems. So let's start off with a basic one. Let's just do, let's say we have 2x minus 1 times, let's just say x plus 5. All right, so this is a good example of where we FOIL, because we can use this FOIL method whenever we have 2 binomials. So basically 2 parentheses, and they have 2 terms in each parentheses. Now, there's also an alternative, but here's basically what FOIL looks like. You take 2x and you're going to distribute that to x. That would be the first, because they're both the first in the parentheses. So we're going to take 2x times x, which would give me 2x squared. Because remember, when we are multiplying variables, we add those exponents that they have. All right, so then the outer would actually be -1 times 5. So once again, and actually I'm wrong, it would be, outer would be 2x and 5, because they're the outer 2 terms on these parentheses. So we're going to take this 2x, multiply it over here to 5. All right, so 2x times 5 is going to give me plus 10x. All right, then the inner terms, -1 is going to multiply by x. So we're going to multiply -1 to x, so it would give me minus x. And then -1 is going to multiply by 5. So that's going to give me -5. So now I combine my like terms, and 10x and 5x are going to add, or not 5x, just x. So it would give me plus 9x minus 5. So there's my answer. All right, now this is already in standard form, and here's why. My exponents are in descending order, least to greatest order, so that would be a good way to write my answer. Now, I just want to show you this real fast. Here's another way you can do this multiplying, which, it's the same process as FOIL, it's just about what you call it. Some people will say distribute twice. So when you distribute twice, what you're basically saying is this. You're going to take 2x and distribute that to x and x plus 5, so it would kind of look like this. 2 times x plus 5, that would be the first round of distributing. The second round of distributing would be -1 to x and to 5. So then that would look like this, -1 times x plus 5. So once again, there's 2 ways you can do it. It doesn't matter really how you do it as long as you know what to do. But those are the 2 different options we have. So now let's make this a little bit harder. Let's look at w minus 7 times w squared plus 2w plus 1. Now, when we multiply this, we are going to actually be unable to use FOIL. Because if I try to use FOIL, it basically doesn't account for this being 3 terms. This is a trinomial, so FOILing's really out of our, it's just out of our ballpark right now. It's not going to work. So what we're going to do is say, okay, this is 3 terms, and this is 2 terms. So what I can do, once again, I just pretty much referred to it, I'm going to distribute twice. So the first thing I'm going to do is distribute w. I'm going to take w, and I'm going to distribute that to w squared, to w, and to 1. So if I were to write it out, it would look like this. W parentheses w squared plus 2w plus 1. All right, so then that would give me w times w squared. Remember, we add the exponents when we're multiplying. So w to the third plus 2w squared, and then w times 1 would be plus w. All right, so now what we're going to do is, and I'm just going to go back just so I can get rid of some of this. Now we're going to do this again, but now when we distribute, let me make sure I rewrite what I already had out. All right, so now when we distribute, we're going to distribute -7. So we're going to distribute -7 here, here, and here. So if I wrote it out, which you don't have to, I'm just doing it so you can see it, it's going to look like this. So -7 times w squared would be -7w squared. -7 times 2w would be -14w. And then -7 times 1 would be -7. All right, so now we're going to end up combining our like terms. So w to the third doesn't have a like term. 2w squared minus 7w squared would be -5w squared. And then we would have w minus 14w, so that would give me -13w. And then we have -7. All right, so now we're finished. And once again, we just want to make sure that the exponents are in descending order, greatest to least, and they would be. So once again, this is distributing twice. All right, so now let's look at another example just so you can see all types that end up happening. Let's say we had a problem like this. Let's say I had -3 times a plus 5 times a minus 2 times a plus 8. Now, there's a couple different ways you can go about doing this, but here's what I would recommend do. I would break this up into pairs. So I would multiply this part first, the -3 times a plus 5, and then I would multiply this part second, a minus 2 times a plus 8. But here's what you're going to have to remember. When we do this multiplication, we're still going to be multiplying what's left over. So we actually have to do 2 full rounds of multiplying here. Well, 2 separate actual lines of multiplying. So first we're going to say -3a minus 15, because we would distribute this -3. But then you're going to want to keep that in parentheses, because remember, this multiplying is actually going to stay in the middle. So now we're going to start another parentheses, because now we're going to FOIL this, a minus 2, a plus 8. So a times a would be a squared. A times 8 would be plus 8a. -2 times a would be minus 2a. And then -2 times 8 would be minus 16. So those are my 2 parentheses. Now, the only thing I really would want to do in this second parentheses is combine my like terms. But once again, this is the part you have to remember. We were still multiplying these 2 separate parentheses. So when we multiplied over here and over here, what we got as our product, we're still continuing to multiply. So we're going to multiply -3a minus 15 times a squared plus 6a, when we combine our like terms here and here, minus 16. So now we're going to distribute twice here, again, just like the previous problem. But this is why these are so difficult, is because it's a lot of work and a lot of multiplying. So what I would suggest you do is just write everything out and Yeah, that's usually the best way to keep from making mistakes. All right, so now I'm going to distribute negative 3a to all three of these terms over here first. So that would look like this. We would say negative 3a to the third, when I multiply negative 3a by a squared, minus, now I'm going to multiply 3a times 6a, so it would give me 18a squared, plus, let's see, negative 3a times negative 16 is going to give me positive, so that's why I said plus 48a. All right, so now we've already distributed this negative 3a, so now we need to distribute negative 15 here, here, and here. And I'll do it in a different color just so you can see it. All right, so now negative 15a squared is what I get when I do this negative 15 times a squared, so now that's done. Negative 15 times 6a is going to give me negative 90a. And then the last round is negative 15 times negative 16, which is going to give me positive 240. So now, I'm going to rewrite this just so you can see it, but here's what I get when I do all of that multiplication. I get negative 3a to the third minus 18a squared plus 48a minus 15a squared minus 90a plus 240. Now, that is a lot, so it looks like a lot, but here's what I want to make sure I do. I just want to make sure I combine like terms. So is there a like term for negative 3a to the third? No, there's not. Is there a like term for negative 18 squared? Yes, it'd be minus 15a squared. So that would give me negative 33a squared. All right, now negative or positive 48a could combine with negative 90a, which would give me negative 42a. And then the last thing I have is 240, so I would just say plus 240. All right, now let me show you one more example and then I'll show you some of the dividing. So one more example is just the setup, really. I just want to make sure you see this. So let's say I gave you this 2c plus 5d, and let's say it's all to the third power. And actually, let's just do this. Let's make it a little bit easier. Let's just say 2x plus 5, all to the third power. Okay, now here's what the third power means, this power of 3, when we have a binomial or any kind of parentheses like this, where there's multiple terms in the parentheses. A lot of people think, well, I just say 2x to the third plus 5 to the third. But that's not really how you do this. That's a common mistake. But in algebra, it has to be one of those mistakes that we stop doing. So what this really looks like is this. We would actually say this is 2x plus 5 times itself, which is 2x plus 5, times itself. So what you end up doing is repeating this parentheses 3 times, and then you're forced to multiply all this. Now, I won't multiply it all out, but you can if you want. Basically, what I would do is, once again, break this into pairs, and you would essentially multiply this first section, then the second section, and then you would have to, well, I guess after that, you just combine like terms and be done. So I won't bore you to death on that with this video because it's very similar to the last problem we did, but I did want to make sure you see when you have a power of 3, or it could be 2 or 4, whatever it is, you just repeat the parentheses and then multiply them all together. All right, so now let's look at the division now. Let's look at dividing. So when we are dividing, here's what we're going to do. Let's just lay some ground rules down. We are going to divide each term. So divide each term in our numerator by our denominator. All right, so each term in the top gets divided by the bottom. And then we're going to rewrite our answer in, once again, standard form, because we just want our exponents to be descending or be in decreasing order from greatest to least. So now let's look at this. Here's what it would look like. Let me get rid of this. All right. So let's start off with this. 9m to the third minus 24m squared all over 3m. Now, if we're dividing by a monomial, meaning just one term, here's what actually happens. I'll break it apart just so you can see it. This is actually 9m to the third over 3m minus 24m squared over 3m. Essentially, this was how the problem was written, but since these two fractions had common denominators, you can shove the top together and just write it over a single denominator. But this is actually what's happening. So what you actually do is you divide each individual term by your denominator. All right, so if I do 9 divided by 3, that gives me 3. M to the third divided by m to the first. Remember, when you're dividing and you have exponents, you subtract them. So this would give me m to the second. Minus 24 divided by 3 would give me 8. M squared divided by m to the first is m to the first, or just m. So now that would be my answer. All right, so let's look at another one, because I'm sure you can probably start to do this without breaking it apart. Like, let's say I have 20x to the third minus 4x squared minus 8x. If you wanted to, well, divided by 4x. I almost left that out. Now, if you wanted to, you could break this apart like this. You could say 20x over 3 divided by 4x minus 4x squared over 4x minus 8x over 4x, because they essentially mean the same thing. So you can do that if you want, but if you want to speed things up, you can essentially do this. You can just keep everything together and just know that you're going to divide each of these by 4x. So if I do 20 divided by 4, that gives me 5. X to the third divided by x gives me x squared minus 4 divided by 4 is 1. X squared divided by x to the first is just x to the first, so it would give me negative x. And then negative 8 divided by 4 is minus 2. X divided by x is just going to cancel and give me 1, but I don't have to write times 1 because 2 times 1 is just 2, so there would be my answer. All right, so now let's look at another one, and we're going to make this a little bit more complicated, just because we're going to add in multiple variables, but this will probably be the last one we do. So just stay with me for a second. So let's say I want to do, let me see here. Let's say I want to do 14 a to the fourth b to the third minus 20 a squared b squared plus 2ab all over, which I have no clue what just happened, all over 2a, or 2ab. Now, here's the problem with this, and honestly, this is just an extreme example just to really test you, but here's the problem. Now we have multiple variables, but once again, we're still doing the same process here, which is dividing each of these terms in the numerator by the denominator. And you can split it up if you want, but I won't, just to save us time. So 14 divided by 2 is 7. Now, since we have an a and a b, I have to divide those separately. So first I'm going to do a to the fourth divided by a, which gives me a to the third. Then I'm going to do b to the third divided by b, which is going to give me b to the second. So that's all going to stay together. That's my first term. So now this is out, and now I'm going to do negative 20a squared b squared divided by 2ab. So 20 divided by 2 would be negative 10, since it's a negative 20. A squared divided by a is going to give me a. B squared divided by b gives me b. And now I'm finished with that term. So now I'm going to do this last 2a over 2b. But here's the thing. 2ab divided by 2ab, that's just two things that are divided by themselves. Or one thing that's divided by itself. Like 2 over 2 just gives me 1. So a lot of people will do this. They'll say, well, I know that these two cancel. They're going to cancel each other out. And that's true, but they cancel each other out to give you 1. Remember, anything divided by itself gives you 1. So I would have plus 1 here, and that would be my answer. All right, so that's multiplying and dividing polynomials. I'll probably at some point upload a video about exponent rules, so be sure to check that out. As always, if this video helped And if you enjoy these videos, it would help me out a lot if you would like, subscribe, all that. And so I'll see you in the next one.